How does a simple steel bar transform into a gigantic 500-meter chain? The answer lies in a symphony of fire, pressure, and engineering on a colossal scale. They are the vital connection for billion-dollar cargoes and the guardians for thousands of lives on the world's largest ships. A single faulty link, and the consequences are catastrophic. Let's dive in and find out how these monstrous chains are made. To shape something of colossal proportions, it all starts with the right raw material. These are solid bars of a high-quality, resistant steel alloy, the basis for creating one of the most durable elements in the shipbuilding industry. Using a bridge crane, operators transport the heavy bars to the start of the production line. The first phase is cutting. The bars are fed into an automatic bandsaw programmed to cut them into segments of an exact length. The saw blade cuts through the dense steel with a cold cut. These ingots have just the right material to become links, the piece that, when joined with others, forms the final chain. Each unit weighs over 100 kilograms and is 5 inches thick. Once cut, the ingots are grouped and stored, ready for the next stage. Hundreds of ingots wait their turn to enter an induction furnace. The heat will allow the pieces to be molded easily. From this point on, the process becomes a choreography of heat and force. One by one, the ingots pass through the induction furnace, where a magnetic field heats them from their core. In seconds, they reach 1600 degrees Fahrenheit, becoming malleable and glowing red hot. The ingot enters the press. The jaws hold it in place. The mold preforms it, and an arm bends it into a precise J shape. Now comes the crucial moment of joining it to the chain. An operator using long tongs inserts the U-shaped link through the last finished link. Then, with precision, he places it in the next station of the press. A horizontal press with a force of hundreds of tons pushes the two ends of the U against each other, forging a closed loop. The link is closed, but the joint is not yet permanent. To transform these two sides into a single piece of indivisible steel, the giant ring, still red hot, is moved to the welding machine. Two copper electrodes hold both sides of the joint firmly in place. An intense electric current is applied. The resistance of the steel to the passage of electricity generates extreme heat that melts the metal at the contact points. This process, called resistance butt welding, creates a molecular fusion, ensuring that the link is as strong at the joint as it is anywhere else. The welding has been a success. The link, now a single solid piece, is removed. The intense shine in the joint area reveals the extreme heat to which it has been subjected. But the welding process has left behind excess solidified material, known as burr. To remove it, the link is placed in a final press. Hardened steel jaws hold it precisely in place, while other surfaces push with enormous force against the newly welded joint. In seconds, the burr is sheared off, cleanly and precisely. The result is a link with a smooth, uniform surface, ready to withstand the most extreme loads. The process will start again for the next link. Simultaneously with the creation of the links, a parallel and equally crucial process takes place: the manufacture of the stud, the soul of each link. It is a solid bar fixed in the center, which acts as an internal support. It prevents the link from bending or deforming and multiplies its resistance. These pieces are the raw material for the studs. The segments are collected and loaded onto another production line. Their destination, like the links, is the furnace. This is the stud forging machine. The steel pieces come out of the furnace red hot, and an operator, with the help of tongs, places them inside the press. A special mold gives them their characteristic shape. The process is fast and continuous. While one piece is being forged, the next one has already come out of the furnace and is waiting its turn. Hundreds of studs are produced every hour. The newly forged studs, still hot, are collected in large containers. Back on the main line, the link, already welded and shaped, is positioned in a vertical press. It still retains the heat from the forge, a key factor for the next step. An operator inserts a cold hammer into the center of the hot link. The temperature difference is crucial. Two powerful side presses are activated, pressing the sides of the link against the ends of the stud. As it cools, the link will contract, trapping the stud with a force of thousands of tons. As an additional safety measure, a qualified welder applies a weld bead at the joint between the stud and the link. This ensures that there is no movement whatsoever, even under the most extreme conditions. But the chain is not finished. It still lacks a fundamental part, the bow shackle, the piece that connects the chain to the anchor. More demanding than a link, designed to withstand more pressure and secure the system that keeps the giants of the sea in place. The process begins with a block of carbon steel chosen for its high strength and toughness. An industrial saw slowly cuts it into sections. The cut takes 15 minutes to complete. The result is a 265-pound ingot that will be turned into a single shackle. Although the steel is very strong, it rusts easily, a detail that will be corrected later. After hours in the furnace, a special vehicle extracts the ingot. The incandescent color indicates that it has exceeded 2200 degrees Fahrenheit and is ready for the press. The ingot is then placed under a forging press. With a force of 6,000 tons, the first blows begin to compact the metal, modifying its internal structure and improving its mechanical properties. A manipulator arm